All right, this is Honors Algebra 2 Pre-Calculus. We're doing 7.4 in Algebra 2, which is solving polynomial equations. So we solve polynomial equations the same basic way that we solved quadratics, which is a subset of polynomials, right, in Chapter 5. So if there's only one power of a variable, you can solve using SADMAP, which is just order of operations backwards. And if there are multiple powers of a variable, we move all of the terms to one side to make sure that the equation is 0. Is equal to 0, that one side of the equation is equal to 0. We factor to solve if possible. If it's not possible, you'll likely need a calculator as there's no equivalent to the quadratic formula for higher degree polynomials. So moving on. All right, so we're going to go ahead and use factoring to solve 2x cubed minus 7x squared plus 3x equals 0. So they already said use factoring, right? The first thing we're always going to look for when we're factoring is a GCF, and sure enough, there is one, right? I can take out an x and be left with 2x squared minus 7x plus 3 equals 0. So either x is 0, right, that first factor, or 2x squared minus 7x plus 3 is 0, right? And there's two ways to do this. I can either try and factor, or I can use the quadratic formula because it's a quadratic. So I could either use the quadratic formula or I can factor. I'm going to always try and factor first, and sure enough, it pans out here. They have the same sign, and I'm going to have a 2x and an x. Since I want a 7, I'm going to put the 3 opposite the 2, right? That'll give me my -6, and I'll put the 1 opposite the x. That'll give me my -1. So you can FOIL to check, and you certainly should. If you do first, you get 2x squared. Outer is a -6x, and inner is a -x. That's a -7, and last is a +3. So I get that either 2x minus 1 is 0, which means 2x is 1, x is 1/2. Right? Or x minus 3 is 0, which would give me x is 3. So I get these three answers. Now, specifically because it said use factoring to solve, it was very likely that this quadratic trinomial factored. But again, you could have used the quadratic formula at this step, right? You have to take out this value first, but then you could have used the quadratic formula for the rest. All right, so go ahead and try a P1. It's the same way. So we're going to look first for a GCF, and we definitely have one, right? We have a GCF of x, and what's left is 2x squared plus x minus 6. So either x equals 0, which is one of my answers, or 2x squared plus x minus 6 is 0, and I'm going to go ahead and factor this. So I see that this is a 2x and an x, and this is either a 1 and a 6 or a 2 and a 3. I'm going to go ahead and guess that it's the 2 and the 3. So most of the time it's the middle set of numbers. So if it's a 2 and a 3, I know this can't be the 2. The reason it can't be the 2 is there was no GCF of 2 in this, so there can't be a GCF of 2 in one of the factors. So if it's a 2 and a 3, it looks like this. Since I want a +1, I think if I do a +4 and a -3, that'll give me a +1. And sure enough, you can FOIL to check. 2x times x is 2x squared. Outer is a +4x, inner is a -3x, that's right. And then last would be -3 times 2, which is -6. So either 2x minus 3 is 0, which would mean 2x is 3, so x is 3/2. That's one of the answers. Or x plus 2 is 0, which means x is -2. And sure enough, there are my three answers. 1, 2, 3. Okay, moving on. All right, so use a graph, synthetic division, and factoring to find the roots. Okay, so this already has an equation where one side is 0, right? There is no GCF, right? So there's no GCF. It's not a binomial or a trinomial. I can cross those off. And although it has an even number of terms, right, it does have an even number of terms, but you can see that the ratio of 1 to -7 is not the same as the ratio of 15 to -9. So it's not going to be grouping. So if anything's going to work, it's going to be synthetic division or graphing, right? So when they say use graphing or synthetic division, this is a great excuse to say, hey, I'm going to use my calculator, and I'm going to educated guess and check. So x cubed, right, minus 7x squared plus a 15x minus a 9. Right, so there's my x squared minus 7x plus 15x minus 9. Let's hit graph. So I can see with my eyes that it seems pretty likely that there's a 0 at 1, right, 2, and it looks like there's a double root at 3. And we're going to talk more about this later, but I can make an educated guess that what's happening is this is an x minus 1 and this is an x minus 3 that happens twice. But let's see how that works. I'm going to use my educated guess to say, hey, let's try 1. And the funny thing is we would have tried 1 first anyway, but it looks like 1's going to work in this case. So let's go ahead and try 1. So I drop the 1 down, I multiply and add straight down. Multiply and add straight down. Multiply and oh, hey, look, no shock there. 1 totally worked, right? So x minus 1 is the factor, and what's left is x squared minus 6x plus 9, which factors into an x minus 3 and another x minus 3. Right, so my three roots are x equals 1 and then x equals 3 with actually what we call a multiplicity of 2, and we'll talk about that a little bit more, but it happens twice, right? This root happens twice, multiplicity of 2, okay. Cool, so we get two roots, but one of them is what's called a double root, and interestingly enough, we'll talk about this moving forward a little bit, but when something has a, so if something has an even multiplicity, the graph kisses, but doesn't cross the axis. So kisses the axis, but it doesn't cross the axis. Okay, so if something has an odd multiplicity, right, like if something only occurs once or it occurs 3 times, then the graph will cross the axis. So interesting side note, and again, you can kind of see that in the picture that I have over here, that at 1, which is an odd multiplicity, this root only happens once, the graph crosses the axis, but at 3, the graph touches the axis but goes back in the same direction. All right, so let's go ahead and try this one, right? So in this case, right, I think I have a slightly different situation. So I go through my list, I see that there's no GCF, I can rule out that it is a binomial or a trinomial real quick because it's not those things. But when I get to the even number of terms, I think I do actually have something that would group. Because I think if I group the first two and the last two, I think that the ratio is the same. I think that a ratio of 1 to 2 is the same ratio as -4 to -8. So I think I can use grouping. Now you don't have to spot that, but if you can use grouping, it can be a lot easier. So I factor out an x squared and I get an x plus 2. When I factor out a -2, I get another x plus 2. So I end up getting x plus 2 times x squared. Oh, it's not a 2, it's a 4. My bad. Come on, brain. It's a 4. Times x squared minus 4, right? So I'm going to get x plus 2, and then this is a difference of squares. So x plus 2 again and x minus 2. So it seems to me that I get x equals -2, and that happens twice, right? Multiplicity of 2. Right? And x equals 2 as the other. So I think I get two answers, and x minus 2 happens twice. And we can actually confirm that if we look at a graph. Remember, what we would be expecting to see on the graph is at -2, the graph kisses but doesn't cross the axis, right? And then at 2, the graph would cross the axis. And you're actually going to be able to see that in just a sec. So -4, we don't need the, oh, I didn't mean to do that. There we go. It's not a 45. I meant to delete the, there we go. And -8. So if we graph this, at -2, the graph kisses the axis but doesn't cross it, and at 2, the graph crosses the axis. So that's, again, not a huge surprise, right? So what this is looking like, right, is at -2, the graph touches the axis but doesn't cross it, and then at 2, the graph crosses the axis, which is pretty cool. All right, moving on. So if x minus r is a factor of, that occurs m times, right, and here we're coming into one where we're talking about exactly the same thing I mentioned here, right? So if it occurs m times in the factorization of the polynomial, then it's called, it has a multiplicity of m. So this is related to the polynomial equation p of x. So in the example we just saw, right, 3 was a root with a multiplicity of 2. So if we go back up here, right, 3 was a root with a multiplicity of 2, right? So what I want you to notice is that when you have an even multiplicity, right, so the graph crosses, doesn't cross the axis, it kisses but doesn't cross the axis. So note that in general you can't tell the multiplicity of a root by the graph of the function alone, but you can tell whether it has an even or odd multiplicity, right? Now they do say, be careful because it might appear to touch the thing but actually cross the axis, and sure enough, if you zoom in, something that looks like this, right, something that looks like this, if you zoom way in, like way in, you might realize it's actually doing something like this, right? And it actually does cross, and there's two little roots there. But in general, you can sometimes tell this from looking, and certainly if you zoom far enough in, you can see. So like if you zoom way in, you could see if this crosses or not. So let's go ahead and walk through some more examples. So in example 3, we're going to use variable substitution to factor. So what variable substitution is, and we've seen this before, is when we have sort of what we call a secret quadratic trinomial. So secret quadratic trinomial, right? So this doesn't have a GCF. It is not a binomial. And it is not a quadratic trinomial, but it is a trinomial, right? But it's not quadratic. So the way we get around this is to say, hey, what if I call some other variable x squared, right, which is this term in the middle, right? Well, then this would be u squared minus 4u plus 3, right, because x squared squared would be x to the fourth, right? So u squared would be an x to the fourth. And then I can totally factor this. I noted that this would factor into u minus 1, u minus 3, right? But then it's not really u, right? It's actually an x squared minus 1 and an x squared minus 3. So and I can keep factoring. This is a difference of squares over the rational numbers. This is a difference of squares over irrationals, right? If you wanted to factor this, you can, but it's going to factor into, so this is irrational numbers. The first one's going to factor into x plus 1, x minus 1. The second one you could either leave as x squared minus 3, which is fine, right? If you did that, you'd get x plus 1 is 0, so you get x is negative 1. You did x minus 1 is 0, so you'd get x is 1, right? And then for your last one, you'd get x squared minus 3 is 0, x squared is 3, so x is plus or minus the square root of 3. So those are your other four answers. That's four answers, right? 1, 2, and then this is 3 and 4. So you could either do that, right? Or if you want, you could actually factor this. It just wouldn't be over the rationals, right? You could factor this into a difference of squares. It would just be x plus root 3, x minus root 3, all of that equals 0, and you still get to the same four answers, right? So either way you go, get to the same answers. All right. Go ahead and try a P3, right? Same trick here, right? There's no GCF. It is not a binomial. And although it's not quadratic, it is a trinomial, right? So this is like that secret quadratic trinomial, right? You're going to say, hey, let's call u x squared. That makes this u squared minus 9u plus 14. And hopefully we're getting to the point where we spot this factors into u minus 7, u minus 2. So I get x squared minus 7 and x squared minus 2. Now, neither of these factor over the rationals, so you have two options. You can either say x squared minus 7 is 0, x squared is 7, so x is plus or minus root 7. Great, right? Or you could say, and you can do the same thing here, right, where you're going to get x is plus or minus root 2. Great, fine. Those are your four answers. The other way you could do this is you could actually factor this. It's just not going to factor over the rationals. It's going to be x plus root 7, x minus root 7, times x plus root 2 times x minus root 2. And then you're going to get the same answers, right? So you'd get the same four answers whichever way you do it, okay? There actually is an interesting third option. So it says use variable substitution and factoring. There's actually a clever other option, which is you could actually do this as the quadratic formula with u, right? So you actually, like just as a side note, so option 3, if you want to get kind of clever, right? You could take u squared minus 9u minus 14 equals 0, and you could do the quadratic formula. You could say u equals negative b plus or minus the square root of b squared, right, which would be 81 minus a 4 times 1 times a negative 14, right, all over 2, right, for 2a. So this is an 81 plus a 56. Seems to check out, right. So I get 81 plus 56. That doesn't come out right. Did I get all those? Oh, it's a positive 14. My bad. Minus 56. It was a positive 14. I miscopied it from up there. My bad. So it's a plus 14. So minus 56. That worked out, right? So that's a 25. So you get u is 9 plus or minus 5, right? Because it's root 25 over 2. So you'd get u equals either 14 over 2, which is 7, right? Or u is 4 over 2, which is 2, but then you'd have to say, oh, wait a sec, after I do all of that, it wasn't u, right? X squared is 7, or x squared is 2, and then that work gets me right back to the same two answers. So I just want to point out there are clever ways. You can't use the quadratic formula on a quartic normally, but because it's one of those secret quadratic trinomials, you certainly could have. Okay, so moving on. That's the end of that video.